Welcome back to Harbour Unboxed. Tim and I are together once again.
Unfortunately.
All right, that's going to take till the rest of the Q&A to stop burning, but that's...
You'll cope.
This new savage Tim, where'd he come from? I don't do a Q&A with you for 3 months and he turns into an absolute savage. Well, anyway, Tim's very happy to be here with me, as I am as happy to be with Tim. We're united to tackle part 3 of the Q&A series. So I think no further comments need to be made.
Sure.
Let's just roll the clip and we'll get into it. Today's sponsor spot is brought to you by Antec and their new Flux Pro full tower case. This new addition to Antec's lineup integrates real timber on the front panel, as well as a textured multi-directional front grille, giving it a unique style while ensuring optimal airflow. As the name suggests, the Flux Pro offers Antec's patented dual lower air intake design and includes support for up to 9 fans, with 6 PWM fans pre-installed featuring a built-in ARGB controller. The Flux Pro also supports real-time CPU and GPU temperature display and a 90-degree I-shift PSU mount to allow for easy cable management. It also supports up to 420mm radiators in the top and front, along with various cooling brackets to facilitate easy installation. The black and white versions are now available for $180 and $185 US respectively, so for more information, please check the links in the video description. Alrighty, this is a future predictions thing, so I'm going to hand that over to my lovely assistant. Your expectations for Battlemage, RDNA4 and Arrow Lake.
Okay.
Nail all of these, please.
Well, I actually have no real information to share, so this is all just, I guess, BS. I think it's pretty likely that RDNA4 will come at CES next year. So as far as like release dates are concerned, RDNA4 next year. And then, yeah, obviously the mid-range rumors, I think that's pretty likely at this point. And yeah, so probably not going to see anything too much more powerful than like a 7900 XT sort of thing, but obviously new generation, that should come down in price. Battlemage, no idea what's happening with Intel Battlemage. They've just fired like 15,000 employees, so maybe the ARC team has just gone with that. Who knows? I think they're still suggesting that it's coming at some point, so whether that's this year or next year, got no idea. Hopefully it's this year, because then there'll be some exciting stuff to talk about.
Potentially, yeah.
Yeah, I mean, ARC's been improving with every driver update and things are getting better. It's come a long way since the initial launch of ARC to now, so it's probably still not at the level, quite the level it needs to be to get like a really strong recommendation, but things are moving in the right direction, so I'm excited to see what happens there, but I'm not expecting it to be like a 4090 competitor or anything like that. I think
mid-range would be fine, because I mean, like you said, it was competing with previous generation entry to mid-range, more entry probably with your 6650 XTs and that sort of stuff.
And there wasn't much of an improvement mid-range and entry-level with the current gen.
That's
so
fair.
It's still currently an entry-level product.
Yep.
So if they can significantly improve performance, and they've shown what the architecture is supposed to be like with their upcoming laptop chips, they've made major overhauls and improvements to the architecture for graphics. So if that can play out nicely for desktop parts as well, then yeah, hopefully we'd see some pretty significant performance gains and more driver improvements and things. So I'm pretty optimistic. I'm excited to see what it can do, and I very much hope it doesn't get cancelled, because that would be bad. And what was the other part? Arrow Lake.
Yep.
I think that's not too far away. Probably should be seeing that in October of this year, so not that far from now. And yeah, it's hard to know what to make of the rumors and things. I think the expectation is the performance will be pretty similar to Raptor Lake parts, so not too much of a performance improvement, but a much more efficient design, better IPC, but potentially lower clock speed, so that will even out the performance a little bit. So yeah, I wouldn't expect it to be like this killer gaming CPU that will drastically improve things relative to a 7800 X3D, but if they can make a part that is similar in performance but solve some of the issues that we saw with 14th gen around power consumption, stability issues, that probably will take years to figure out what's happening there, because it took years for 13th gen. So yeah, all that's to play out, but new platform could be exciting as well. What they do with that, potential future support, things like that, who knows? So yeah, I mean, I'm interested in Arrow Lake to see what the architecture is going to be like. What improvements are they making? What are they going to do with the new platform? It has the potential to have exciting things about it. It won't just be a 14th gen refresh. it'll be some sort of new design and things like that, which is always interesting to see. So yeah, interesting parts coming out throughout the next probably 6 months-ish on the CPU and GPU front. So we're getting to release season, really, so should be good.
I'm here for it.
Yeah.
Is AM5 still exciting long-term, despite the overall poor performance of Zen 5 compared to Zen 4? So we sort of touched on this already in a previous question, but not for obviously this part of the Q&A series. So is AM5 still exciting long? No, it's not, is it?
I think it's gone from it would have been exciting if Zen 5 was good to now it's not exciting.
Yeah, it was previously much more exciting before Zen 5 arrived, which is kind of crazy that it's gone heavily backwards. Yeah, at this point in time, not as exciting. What the future holds for AM5, obviously we don't know. There's still the Zen 5 X3D CPUs to come on AM5, so maybe they'll help salvage at least this generation release. And then Zen 6 hasn't even been confirmed to be on AM5. And Tim and I have talked about this privately at length and even on the podcast a bit.
Yeah.
I'm of the opinion that Zen 6 will definitely be on AM5 for reasons no other than it absolutely needs to be, and they're my feelings, so don't hurt my feelings.
I think it'd be heavily misleading if it wasn't. Like, the implication from what AMD has said is that by supporting it to 2027, that a new generation will be supported on that platform. My only hang-up is really that they haven't confirmed, like Zen 6 is now on roadmaps.
Yeah, they've hinted at it with the roadmap and then said we're extending the support. And those two things is like, they didn't say the thing, but it's heavily implied.
Like, they've said it's supported to 2027. They've confirmed Zen 6 is a thing, but they haven't confirmed that Zen 6 will be on AM5. So that's my only hang-up, is that with companies you have to be very particular about the language used, and if they're not saying something explicitly, it's usually because they're trying to weasel out of something. And what we've seen with AM4 is obviously AMD is still saying that AM4 is a supported platform today when there hasn't been a new CPU launch, and by that I mean a new CPU architecture launch, for many years now. So they're keeping it alive by releasing parts like the 5800 XT, which is not a new CPU. It is basically the same part that we had previously, but because it's a new CPU, the platform is extended. And so there's the chance that they could do that with AM5 by refreshing Zen 4 and Zen 5 parts for years to get it up to 2027. I think that would be very misleading, but because things haven't been confirmed, it's hard to say which way they go. But I think if I was going to say one way or the other, I think Zen 6 is more likely to be supported. But even if it is, it's not that exciting.
Well, it's not, nothing's guaranteed there.
Because who knows what the performance is going to bring. Is it, if it's only 20% faster than Zen 5 or something that's not that much faster than Zen 4, so from start to finish on the platform, it's not that much of an improvement. Yeah,
with Zen 4, it started off a bit rough, but motherboard pricing got down to a more reasonable level. DDR5 memory is got right down to a reasonable level. So all those things have shaped up to AM5 being an exciting platform, something you upgrade to invest in. And then to take it that next step would be, look, we've taken the next step in terms of CPU performance, but that hasn't happened, at least for the desktop and gaming side of things. So you're essentially, if Zen 6 doesn't arrive for another 2 years, you've essentially gone 4 years with the same performance, or near enough to the same performance, excluding the upcoming X3D chips that may change that.
Yeah, that's right. And I think it changes the perception relative to Intel platforms as well. It goes from sort of people could have early adopted and get a head start on a new generation with AM5 to maybe if you had waited, you would have gotten a similar sort of experience from Intel, or maybe there's not too much difference. So those sort of things play into it. But
the platform longevity argument's almost gone entirely out the window, because Arrow Lake will have at least another generation on that platform. So if you go comparing Arrow Lake with Zen 5, it's the platform longevity angle's really almost not even worth discussing, because it may not even be a thing. We don't know. That's right. So you recently praised NVIDIA and AMD's strict limits on factory overclocks. I don't remember the exact context of that, do you?
That would have been around the Intel Power
discussion,
I think. around the validation of certain power limits and things that was being done.
Oh, yeah, that might have been at Computex.
Yeah.
But these brands also restrict the voltages and power available for manual overclocking. Radeon even hard limits clock speeds. Do you agree those are bad for consumers? I mean, they're bad for overclockers. Whether they're bad for consumers at large, I don't necessarily think so. I mean, ultimately, it would be great to have the product stable and well defined out of the box. Like you're getting the most out of the product without going to or beyond the point of diminishing returns. You're not compromising stability. It just works. That's ultimately what you want as the out of the box experience. And then, it'd be great to have the freedom to tune and do whatever you want. But at the same time, there has to be enforced safety limits, like known safety limits. If you apply this much voltage, that's deemed excessive voltage and will kill the chip quite rapidly, if not instantly. So you don't want those sort of situations either. You still need some defined limits, or it has to be very difficult to override those limits for those that are using like liquid nitrogen or whatever. So I'm all for it being highly customizable and tunable, but you also don't want people who are getting into overclocking, novice overclockers or whatever, blowing up their parts because they didn't realize you couldn't make this adjustment or whatever. And we haven't really been seeing that either.
I think you run into issues with GPU overclocking where people try and pin overclocking related issues on the manufacturer. So if you've pushed your GPU too far and you're getting black screens or artifacts or system crashes or whatever, you might blame that on the driver as opposed to the overclock that you've done, which, companies are very protective of their reputation around drivers, especially after that's affected, say, AMD's drivers for a long time. So companies are not willing to sort of go, well, you can do whatever you want, but, we don't really want the blowback of you overclocking your CPU or GPU too far and then having issues and then either RMAing products and trying to go through that process when it's kind of your fault for killing your product, or having issues that they're then attributed to things that are not really the company's fault. It's more the user's fault. So I think that's why we've seen GPU overclocking being limited, because there was a time when you'd buy a GPU and basically there was like a 20% performance margin there, and most people would be experimenting with overclocking. As time's gone on, if you're looking for those 20% gains, you kind of have to do very extreme things that are not going to be stable. So if you're trying to apply the sort of, you can always overclock a GPU, and then now you try and do those similar overclocks and it's really not an optimal experience anymore, then people are going to be complaining about stability and, why can't I overclock this? I always used to be able to do it, and now you're saying I can't anymore. So I think that plays into why there's limits for those parts. And how often have we seen, CPU crashes and things being attributed to, not with the Intel side of things, but my game crashed, and that wasn't the overclock. Surely that was the game I was playing, or that was the drivers or the memory or something. When it was actually just you were running your configuration unstable. So it's a tricky one. I think companies are trying to avoid that, and really, I think a lot of the time these days, there's just not enough headroom to justify significant overclocking limits. They're pretty well tuned out of the box these days for maximum performance.
Why doesn't AMD increase core counts to compete with Intel in productivity workloads? They have the technology with Zen 5C. I don't think they need to, really. For a lot of productivity workloads, especially in the case of the 12 and 16 core parts, which you'd be buying Ryzen 9 if you're primarily cared about productivity, they're generally faster for a lot of workloads, especially when you power limit Core i9 and Core i7 parts. So, there are some applications where those E-cores really do work quite efficiently, but there's a lot of applications where efficient cores just aren't as advertised, and you find the 12 and 16 core Ryzen 9 parts delivering better performance and much, much better power efficiency. And that is the other side of the angle, right? When it comes to, especially to server stuff and those more intense productivity workloads, the efficiency, as in power efficiency, becomes a huge component. And if Intel's, 10, 20% faster, but they're using twice as much power, then it's not really a win. There'll be certain instances where time is money, and the time factor matters above all else. But in a lot of core heavy productivity workloads, the 12 and 16 core parts are as fast or faster than what Intel's 14th gen offers anyway. So,
Hmm.
and then it ends up becoming a messy sort of, it's not as simple as just adding those extra smaller cores and it all works well. You've seen all the headaches, even dual CCD designs are causing with scheduling stuff. So it's just another layer of, and the E-core rollout wasn't exactly smooth either. So
It broke a whole bunch of games.
yeah.
Yeah, I mean, really the productivity angle with Intel CPUs is that for the mid-range parts, so like your Core i5s, you get boosted multi-core productivity performance because they offer more cores.
Mm-hmm.
Whereas if AMD really wanted to compete with that, they don't necessarily need to make higher core count processors because, as you said, the 16-core part is pretty similar in performance to the highest core count Intel part. They just shift stuff around in the product stack.
Mm-hmm.
They could make the 8-core a Ryzen 5 part if they really wanted to compete better with productivity. They probably would need to go a little higher than that in some instances to compete. But the amount of cores, they could just shift it around a little bit. So if there was, a 14900K Arrow Lake part that had even more cores and was destroying and crushing multi-core productivity benchmarks and AMD's best part couldn't compete, then they should probably add more cores to their design. But for a lot of people, like for us, right, we need fast CPUs and multi-core CPUs for our video editing and stuff. I know Balin uses Threadripper, so we're not really talking about desktop platforms, but most people who time is money sort of people who need high multi-core performance are not necessarily buying mid-range affordable parts. It's more geared towards the higher end stuff. Like for us as a business, right, we wouldn't go, we could get a little better bang for buck by buying a $200 CPU instead of a $500 CPU. So we'll buy the $200 CPU. It's like, okay, it's a $300 difference, done.
Mm-hmm. Mm-hmm.
It's for business reasons. It just makes so much sense.
Business expenses and whatnot. It's all managed a bit differently to personal expenses.
And that's why we see those companies in the stability issues at the moment. Using 14900Ks and 1300Ks for game servers. They're not using the Core i5 parts. Mm-hmm. They're bulk buying the fastest parts because for business and server applications, you tend to want for workstations the highest performing processors, and you pay the appropriate price for those. Which is why I think it matters a little less that a Core i5 is significantly faster for Blender than a Ryzen 5 processor. But most people who are doing CPU Blender rendering, which let's be honest, most people are probably using a GPU anyway, but let's say they're using CPU Blender rendering, they're already looking at only the Ryzen 9 or Core i9 parts.
Yeah, certainly professionals.
Certainly professionals. So it's a small niche use case for people who want those bang for buck multi-core productivity options, but most people want to know about, in that price range, gaming performance, want to know about the general everyday application performance, and that's why parts like Zen 5 was so disappointing. It's because they didn't offer those gains for the applications that someone buying a Ryzen 7 or 5 processor would be using them for. Mm-hmm. So, I don't think the core count thing, it would be nice to get more cores, and hopefully we see that with the future generation, but competitively right now, it's not as essential.
Mm-hmm. How much of an opportunity is the flop, that was our word, so not everyone necessarily believes that, of Zen 5 for Intel? So AMD fumbling with Zen 5, at least on the desktop gaming front, workstation, server, well, probably more server and AI stuff, probably a slightly different story. How much does that open the door? How much of an opportunity is that for Intel? I mean, it doesn't really change anything for Intel in the sense of what they were going to produce anyway. Like Arrow Lake, regardless of what Zen 5 did or didn't do, Arrow Lake was always going to be what Arrow Lake is going to be.
Designed years ago.
So in terms of opportunity, it just, obviously not releasing something awesome or mind-blowing or whatever, like it's seen weak sales. I guess that opens the door. It's hard to say, right? Because all the reviewers are saying, oh, gee, this thing's so bad, just buy Intel. They're saying, gee, this thing's underwhelming, disappointing. It's still a good product. Like, it still works as well as Zen 4, which doesn't make it a bad product. But in terms of pricing, it's not great, so just buy Zen 4. So they're not necessarily recommending Zen 5, but they're still recommending AMD. So what that does for Intel, right now, nothing. Arrow Lake needs to kick it out of the park, and then people might start turning around and saying, well, discounted Zen 4 or discounted Zen 5, not really worth buying because Arrow Lake is this much better or whatever it may or may not end up being. So It's certainly helped. It's given them a chance, I suppose.
Yeah, I feel like if there weren't stability issues with their current generation parts, they've sort of they would have had more of an opportunity to be taken. I feel like that's probably been negated a bit by people that will be turned off from Arrow Lake regardless, just because of the situation around the stability issues. Even if Arrow Lake has flawless stability, there will be people that do not buy it or consider it because of those reasons, and that's affected GPU drivers and things. Whenever there's major issues with stability, people tend to stick to one team or the other for quite a while. So that's affected them. But let's just ignore that angle for a moment. I think the opportunities that they have, as you say, the CPUs are the same, so they can't just suddenly make the CPU better. They can make it more appealing based on pricing the CPU more appropriately. So if Zen 5 was really good, then and Arrow Lake it is what it is, they potentially have to price it lower and lower and lower to make it more and more competitive, maybe to the point where they can't price it low enough if the product is underwhelming. Whereas because Zen 5 hasn't performed to the expectations that many people had for it, they can probably price it more around more profitable levels. Now, that's good for the company. Maybe it's not good for the consumer, but the more margin that they have, the more room there is to flexibly price products for consumers to make them appealing. So that's one angle. And then obviously the platform stuff that we've talked about throughout these Q&As, where AM5 is sort of weakened because Zen 5 isn't offering too much of an upgrade. So the start to end performance gains on AM5 are probably not going to be as attractive for people. So that's one potential angle of negating the sort of platform longevity of AM5. Potentially Arrow Lake will start at a very similar position to AM5. And as you've seen, like it affects like what's the cheapest part you can get on an AM5 processor right now. It's a Zen 4 part. There's not that much to be gained going to Zen 5. It changes some of those dynamics around what you would buy on the platform and what you can expect from the next sort of generation. So yeah, that's helped them a little bit. And there's all those sorts of angles, but fundamentally, if they don't execute on the processor, like if the processor isn't good or doesn't improve substantially in various ways over 14th gen, a lot of that is not going to materialize in any way. It's not going to be a factor. So they have to make the CPU itself and the generation good to start with. That's the primary sort of goal. And if they can do that and price it well, they've got more of an opportunity now than they potentially had if Zen 5 improved performance by 15 to 20%. That becomes a lot harder. So there's all of that. But yeah, if I was going to guess how this next generation would go, I think that Intel will find it hard to turn things around in one generation, and will find it hard to regain trust after stability issues in one generation.
Yeah, but if this is the rebuild generation, it's better having it this generation
than
the rebuild generation being, another 2 years from now.
Yeah,
so the
exactly.
sooner they do that, the better.
Yeah, sooner they write things on the right track. And like I said, they've got an opportunity has been handed to them to get that out of the way now and sort of reset things without losing too much ground. Because if the processor is the flagship part is not improving performance all that much and is targeting efficiency, if Zen 5 is 20% faster, their part would look quite a lot slower. But if things are more stagnant, then there's opportunities they're not losing that much in performance, and things change from there. So it's going to be an interesting generation to see how that one plays out. And yeah, Arrow Lake isn't too far away, so we'll see. What are your feelings on CAM2 memory? I want it to be the next cool feature for a motherboard. However, isn't the limiting factor for memory speed the controller on the CPU, or something like Ryzen liking DDR5 6000 for 1-to-1 ratios?
Yeah, for the current CPUs we have, that's true. But the advantages of CAM2 go beyond at least what we have right now of supporting higher memory frequencies. It makes it easier to support higher memory frequencies, for example. But there are other aspects as well, like, for example, just cooling the memory. That's a whole lot easier. It's a more compact design, and it allows for denser memory capacities without sacrificing things like memory frequency, memory performance. So there are certainly advantages to it. It's not something that we're in desperate need of, and CAM2 here is to solve a real problem. It's just it could be a step forward into improving things as we go forward, with and sort of like what we talked about with CAM2 on graphics cards, for example, like that sort of technology, while I don't think it's needed, could could potentially address that problem, whereas your traditional DIMM modules couldn't.
Yeah.
So, yeah, it's a really interesting technology. I think it is the way forward anyway. I think that's ultimately where things will end up going. So I don't think it's like a prototype thing that will come and go. I mean, it could, but I don't think it will.
And how long has the DIMM design been around for? It's pretty old technology at this point, that sort of design.
Yeah.
So it kind of makes sense that at some point you're going to have to move past that to a newer technology.
Mm-hmm.
And for a lot of the reasons you've said, that makes sense.
Mm-hmm.
Are game areas specifically selected, whether they're used for CPU or GPU testing? And this comment was based on a GN comment that they use a specific city area in Baldur's Gate 3, and it was selected due to its heavy CPU use. So when you're selecting scenes for testing, are you optimizing like the CPU stuff for CPUs, the GPU stuff for GPUs? How do you decide that?
There have been instances in certain games where we do have a GPU test scene and a CPU test scene, but for the most part, it's the same scene that we use. So we'll find a demanding area of the game, and generally that means it is CPU demanding. Like, for example, we do that in Starfield. So we found one of the town sections of Starfield. We did the same thing with Shadow of the Tomb Raider, for example, as well. We tested a village section there, which was much more CPU demanding than just walking around in the game, and we did the GPU testing there as well. It was just a good system benchmark. And when you do the GPU testing anyway, using the fastest CPU available or one of the fastest CPUs available for gaming, so you're less likely to be CPU limited. Also, you're usually testing GPUs at higher resolutions to increase the GPU load. So it's more the test configurations in terms of settings really dictate whether you're testing a CPU or a GPU. And of course, we've had the whole low resolution 1080p problem with testing CPUs for a while now, but there's a reason why we do that when we're targeting CPU performance. So, yeah, does that answer that question?
I think so.
Cool.
How long do you think the viability and usage of AM4 will last? Do you think AM4 would still be usable and perfectly fine by the time that AM6 will come out? So what's that, 2028?
Yeah, it's a long way away.
Probably not.
Probably not, but yeah, it depends, because it largely depends on what AM4 CPU you're talking about. If it's a 5800X3D, which is, it's a crude measurement, but roughly equivalent to like a Ryzen 5 7600 or 7700, which I guess you can now include new Zen 5 CPUs in that as well. It does depend on how memory bandwidth sensitive, demanding the game is as to how those numbers pan out. But they're pretty similar. I guess the point is 5800X3D is still a really great gaming CPU that has plenty of legs left in it. And the memory angle aside, my assumption is if a Ryzen 5 7600 or Ryzen 7 7700 or roughly equivalent CPUs are still usable in playing the game, then your 5800X3D is probably also usable and playing the game, especially if you're, again, are we talking about Counter-Strike 2 at 600 frames per second, or are we talking about, Forbidden West at 60 FPS? Because if we're talking about, lower frame rate gaming, then you're almost always going to end up GPU bound for the foreseeable with something like a 7800X3D. But yeah, the first gen, second gen, third gen, so what are we talking about? The 1000, 2000, and 3000 series, they're pretty well out now. It's really the 5000 series, and even the non-3D V-cache parts are becoming pretty slow. You're getting like at least a 20% uplift on average with the 3D V-cache, so that's sort of that 20% gain catches up to the next generation. Yeah. So anyway, I don't know, it depends. There's so many variables, the games you play, all that kind of stuff. But I guess generally speaking, parts like the 5800X3D are going to be perfectly usable for years to come, I would think.
Yeah, I would say so. Certainly if it's as good as a mainstream entry-level, even mid-range CPU today, it's probably going to be pretty okay for a while. We'll just have to wait and see what sort of games do in terms of CPU usage. You've talked about how even at 4K, there are some scenarios where you can create CPU limits, even with visually impressive games and those sorts of things, depending on the sort of quality settings you're interested in, whether you're using upscaling, how many frames you want. So as we get more and more demanding games, that threshold of frame rate that the CPU is capable of is probably going to drop. But if you're comfortable keeping your CPU for a long time and are comfortable with not necessarily having super high frame rate experiences in single player games, it's probably going to be pretty good for a while. And I would imagine that come 2028, that there are still going to be games that will run just fine on those sorts of parts, especially depending on the sort of other hardware you've got. So it really looks to be like, that platform headlined by that part, because as you said, you can probably discount the older stuff, is really sort of like going to be a golden platform for a lot of people, like back in the early days of like Sandy Bridge and Ivy Bridge. Those parts lasted a long time, and really you were seeing people comparing those parts to like Zen Plus, Zen 2 type things, going, is it time for me to upgrade? So that's going to be the case, I would imagine, with this generation. So around 2028, we'll probably start thinking about next generation consoles, so like what the PlayStation 6 and stuff will be using, and that always has the potential to increase CPU requirements, like we sort of saw around this latest generation, the current generation that we're in. So by then, new consoles will probably be around the mark, so we'll see what happens there, but I would still imagine the vast majority of games would work to some degree.
All right. I've recovered from Tim's initial burn. I enjoyed this Q&A series.
Yeah, it's good. Good questions, at least.
Phew, all right. Wasn't sure where that was going to go. It was really, really good. Great to do it again. And hopefully we can have some more interesting Q&As to sort of round out the year. So we'll see what the coming months have for us. There's the potential. There's the potential.
Always potential, although we'll see what the releases are throughout the rest of the year, but we'll see.
Yep. But anyway, Float Plane Patreon, check that out if you're interested. You can get some cool Harbour Unboxed perks, but if not, perfectly fine. Tim might hate you for it, but I'll give you a pass. And that's really all we've got for this one. So I'm your host, Steve.
I'm your host, Tim.
See you next time.